Okay, so our first example is going to be that a hiker starts at her campsite and walks 2 kilometers west, 30 degrees of south to a waterfall. Actually, you say this 30 degrees south of west. That's how you say that. Okay. So maybe this hiker's campsite is here. Okay. We're going to draw our little like compass in here. And this is the south, west. Okay. So here's her little tent right there. And we want her to go 30 degrees south of west. So west, I'm going to extend this little axis out. We want her to go 30 degrees south from the west side. She's going to go 2 kilometers in that direction to the waterfall. My terrible waterfall. Okay. What questions do you have about that?
Can you explain it over again, please?
Yes. So, when you're given compass directions, you're going to be given like a direction, an angle, and then another direction. What that means is you're starting here. This is where you're at, okay? And you're going to go however many degrees in the new direction. So she starts at her campsite. We drew in a little compass at her campsite to indicate north, south, east, and west, okay? And it says that she walks 2 kilometers, so that's the distance. So that's how long this line should be. 30 degrees south of west. So we are going 30 degrees south from the west direction. Okay, so from the west axis, I'm going to move towards the south axis by 30 degrees.
I got it.
Perfect. Okay, do you guys need a minute to write this down, or can I do the next one?
So about the south of west 30 degrees,
Yes.
you start at west, right? And you go 30
Yep.
degrees towards the south?
30 degrees what south?
30 degrees towards south, right?
Yes, exactly.
Okay, all right.
Yeah. So if I said like, maybe I'm going 45 degrees east of north. Okay, so I would draw out my compass. This means that I'm starting from like the north piece, the north, and I'm going towards the east. So I would move my angle from the north axis towards the east axis, 45 degrees. Okay, does anybody need time to copy this down, or can I flip over the paper? Okay, I'm going to assume that I can flip the paper. Okay, so the last thing that we're going to cover with our applications is angles of elevation and depression. Okay, so we will do 2 examples with this one to do both elevation and depression. Okay, so regardless of which one you're doing, you always start from a horizontal line. Okay. So, and it's pretty easy to tell the difference between these two because of their, like, the words. So for our first example, we have from the top of a cliff a hang glider. These are super outdoorsy examples. I hope you're enjoying it. These, her landing pad. Looking at an angle. Do you guys think it's going to be elevation or depression? If I have my hang glider up here, the landing pad's down here, and she's looking down at it. Oops, I did a really bad job. So she's looking down at it. Do you think that this is going to be an angle of elevation or depression?
Depression.
Yeah, so an angle of depression of 16 degrees. Now it always starts from a horizontal line. This horizontal line is going to be where her like normal line of sight is going to be. I should have drawn all of this from her face instead of from the cliff. So we're going to just edit this picture slightly so that everything is coming from her face. So here's my hang glider. There's my cliff. There we go. Sorry about that. Okay, so she's looking it down with an angle of depression of 16 degrees from the top of the cliff to her landing pad. And this is angle of depression. Okay, so angle of depression is when you're looking down from something. Angle of elevation is going to be when we're looking up. So this next one, a firefighter sees a cat in a tree at an angle of elevation of 52 degrees from where she's standing. Okay, so again, I'm going to have my little person, my firefighter. I'm going to have tree. I'm going to have a cat. Okay, and my firefighter is looking up with an angle of elevation of 52 degrees. This is not to scale. Okay, what questions do you guys have? Okay, so you can kind of think about these angle of elevation and depression lines as like transversals, a transversal going through parallel lines. And so you can have an angle of depression or an angle of elevation, depending on how the problem is set up.
Miss Roberts,
Yes,
can you raise your paper just a little bit, please?
of course.
Thank you.
And then let me know if you guys need me to slide it down so you can see the parallel line and transversal, not that it's very complicated to remember. Okay, are there questions? What questions do you guys have on angles of elevation and depression? Okay, if there are no questions, so we're going to move on to examples that contain the triangle trig that we've been doing in our other work. Okay, so we're going to work on the applications of non-right triangles sheet. I have steps for solving at the top of it. This sheet is listed on Canvas. So feel free to go ahead and pull that up. You do not have to do your work on this sheet, but I have done the drawings for each of these particular scenarios to try to help you out and make sure that this concept makes sense. So I'm going to go ahead and move this sheet. Okay, we're going to start working on this. There's also a PowerPoint up, and that PowerPoint basically steps you through a lot of this work. But I decided that we should probably go ahead and start this just to get, because we only have like 6 minutes left. So we're going to start number 1 together. If you feel like you need more practice and you need to step through the problems a little bit more, feel free to open up that PowerPoint and start working there. But during our asynchronous time. For now, if you'll follow along with this. So in number 1, it says 2 ships leave a harbor at the same time. The first steams on a bearing of 45 degrees at 16 kilometers per hour. Okay. That's what this means right here when it has kilometers h -1. That h is to the -1 power, so it means per hour. Okay. And the second is on a bearing of 305 degrees at 18 kilometers per hour. How far apart will they be after 2 hours? Okay, so I'm going to draw, well, we've already got each of them drawn out. Okay. And so our first one, we're going to maybe call this one boat A, and then maybe this other one boat B. Okay, so I'm going to have boat A here and my boat B over here. Okay, and I picked that because boat B is going slightly faster, so they're going to go slightly further. All right. And it says, so remember our bearings. Okay, so it says on a bearing of 45 degrees. Remember the bearings always start at the north and then travel clockwise. So this bearing is at 45 degrees, which means that if I bring this up a little bit, and this is our north, our 45-degree angle should be right here, okay, for boat A. Okay, and they are going 18 kilometers per hour, or 16 kilometers per hour. Boat B is on a bearing of 305 degrees. We still have to start from the north and go all the way around, okay? So 305 starts here and goes all the way around to here. What will that make this angle be?
55.
Yeah, good. I should have 55 degrees right here.